Clicked on to the Thursday night discussion. Spring is here today. Temperatures feel good. Temperatures are going to feel really good this weekend. Actually be a little bit above normal. And winter, though, does not want to give up. And next week, it's trying to develop a very, very big storm. You can't really say that's going to happen, and you can't say it's not going to happen at this time. We do have the seasonal component against it. It is late March, and storms have happened in late March, but they're very rare. But one thing we're going to really have is a lot of cold air in place ahead of it due to the front that's going to come through our area on Sunday. And that creates a gradient for the storm to form. And then it comes down to a timing issue. So the cold air will be in place. We'll have the energy in place. It's just a matter of how does that energy interact, and will we get that big storm. So here's the European model. As we get to this weekend, Saturday, very warm air, up into the 60s, going to be beautiful. Here comes that cold front coming in right here, as shown by this blue line. This will drape across the region into Monday morning and really set the gradient for a storm system to form. Now take a look. As normal, it's always about energy, right? So check this out. This is a very, very defined split flow in the jet stream here, okay? So you have this disturbance right here, and you have all this energy coming off the Pacific right there. And you can actually see that on the water vapor imagery. Here's all this energy. It's going to come onto the southern stream. There's some energy from the south here that runs across like a train. Then we have northern impulses diving down. So all this convection and moisture out in the Pacific is going to affect our area next week, as you can see here. And as I've been talking about, I talked about this in late February, this split flow regime combined with cold air already in place across our region could produce trouble along the East Coast. And you can see the European model tries to combine these two disturbances and develops a very, very deep trough over the east on Wednesday and tries to bring a storm right up the coast. Now the GFS doesn't do that so much. So the GFS, basically, the timing's a little off. So see, the European is a little further back. GFS is a little sped up, so it tries to combine the energy, but it does so a little far offshore. So if you look at the surface map on the GFS, you see the storm's way offshore. On the European, we have a pretty significant storm developing here. Okay, that's a big low. It goes down to the 960s, and that's a blizzard for eastern Massachusetts. It gives our area quite a thumping as well. But again, it's that small difference, European, GFS, and the upper air pattern that results in either a solution like this or a solution like that. So we have to watch it. Now, so a lot of factors are against us in terms of the season, but the cold air is in place, like I said. Taking a look at one of the ensembles, basically what this does is it takes a look at what the weather patterns will look like next week and says, well, what other times in history did the weather pattern look like this? And the one at the top is the highest match, 92% correlation, 1974, 328. But I can't ignore the fact that it has 1993, 316. That was a superstorm of 93. And over the last couple of days, it keeps hinting at that for the analog, saying the atmosphere is in a similar setup. So I see something like that. I have to try to take this storm a little bit seriously. On top of that, I take a look at what's called the European weather ensembles. And what these are is it takes a European model, and a model is based on input. So it says, well, what if the inputs are wrong? So let's change these inputs from X to Y on this run. Then on the next run, we'll change it from Y to C. And you could see each one of these different runs changes the initialization inputs, and you could see all these members, do they have a storm? And if you look at this, this is half the members. All of them are pretty much showing there's going to be some sort of a storm on the East Coast. Okay, and if you look at the other half of the members, they're showing the same thing too. So the fact that we have agreement from the ensembles, which purpose is to test the main model for error, okay, the fact that we have analogs that support us, the fact that we have cold air in place, I have to take this storm threat seriously for Wednesday. Now, how much snow could it produce? It's so hard to say, and I mean, it's all timing, because if the timing's off, then we just have a cold weather pattern with some snow showers. But if everything was to come together perfectly, it would be a historical snowstorm. If things marginally come together like this, we'll have a good, say, 6 inches where we live, and up in New England would have over a foot. So there's a lot of spread here, but I think you're going to see a storm occur. It's just a matter of the timing, and I can't even answer that question right now because I would just be guessing. But the ensembles agree, so I'm going to take this seriously, so keep checking in. Next couple of days, we'll have a lot of updates and see, okay, how much will this storm really wind up? Will it be something like this, or will it be something offshore like that? Keep checking in, and I will keep you updated.